a reason for it, because as I told you yesterday, addition is a binary operation, so you have to add them two at a time. So if you put them in a different order, then you'd have to add this number to this number, and then that one to that one, and then the sum to that one. So what we do is we turn them around. Before long, you just turn them around in your mind. You turn them around so that you can add them easily. Okay, what's the next step? Emma?
Put parentheses around 40 plus 60 and 69 plus 60. Do you have to write another step? Or can you just write it?
No, you have to write another step because you've got to make sure you've written out the right word beside it. So which property is that?
Yes.
The associative property. All right, so then we add them. What's 40 plus 60, everybody? And what's 69 plus 31? And what's 100 plus 100?
200.
Wasn't that tough? Okay.
Like the program says, do you have to label them commutative or associative?
Well, if you just use the associative property, for instance, maybe you might have a problem and would say, oh, this is kind of what I'm making up off the top of my head. And you know that I'm not real successful at that. Suppose you had a problem that said 5 plus 7 plus 17 plus 5. Okay, if you were going to associate them, you would, and you wanted to do it in order, it would be like that. If you're only going to do the associative property, then that's what you have. If you're going to commute something, then you have to move them first. That make sense?
You just like write the associated.
Yes, for a little while you have to write it. And you're not going to have to write it forever, no, but you do until that's firmly in your mind. Because you are going to, at other times, be required to say, hey, what property did you just use? And it's easy to forget if you haven't practiced it. So you will be writing them all out for the time being, yes. All right, now there's another one. Well, actually, there's more than one. This one seems kind of silly. But it says, say you've got the number A. A equals A. There's a name for that. It's called reflexive. It's one of the things that helps people when they're first starting out, when you've got some kind of an algebraic equation or expression where you have two variables in it. Everywhere where you have an X, it has one value. Everywhere where you have a Y, it has one value. But this X isn't the same as that Y because of the reflexive property. So we have it, I mean, that's what it's called, the reflexive property, like looking in the mirror. You know, you look in the mirror and there you are. Not too tough, right? Okay, and then there's another one. Now this is when you've got just one number. It's reflexive. There's also the one that says, if you have, well, we did that to begin with. If you have 3 plus 7 equals 7 plus 3, there's a name for that too. It's called the symmetric property. Now the only difference between symmetric and reflexive is you've got more numbers here. Reflexive is just a number equals itself. Symmetric says this side right here is equal to that side because they're the same.
What's the difference between symmetric property and commutative property?
The commutative property I turned around. Symmetric property could be this. Or symmetric, yeah. Could look like that. You see that?
Yeah.
Okay, so you got it exactly the same on both sides. Or you could have commuted it, like we did here. It was still, they're still symmetric because they're the same on both sides.
Would it be reflexive if it was like
No. No, would it, yes, no. Not really. It's close to it because unless something had said it was 7, like 7 equals 7. In geometry, they do lots of proofs where they will end up saying, triangle ABC is congruent to triangle ABC. That would be, you aren't going to do that, so don't worry about it. Okay, then there is one more. I've always called this the Santa Claus property. It says I've got A equals B and B equals C. The transitive property says, okay, then A equals C. All right, now let me show you what I'm talking about. Suppose it said, you say 3 plus 3, let's do this. 7 equals 3 plus 4. And 3 plus 4 equals